Good day, grade 11 students. Today we are going to discuss about example number 4, and that is proving a certain sigma notation. That is sigma, a certain formula 2i minus 1 with the first term I is equal to 1 and the last term is n equals n square. So step number 1, show true for n is equal to 1. So here is our given, and then let's substitute our I with the 1 as its equivalent, and then 2 minus 1 is equal to 1. 1 is equal to 1. Therefore, step 1 is true. Next, step 2, assume true for n is equal to k. So we're going to change our n with k, so k squared. So here is now the given. Let's enumerate all the terms based on our sigma notation. So first term, 2 times 1 minus 1. Let's change it, and then 2 times 2 minus 1, and then 2 times 3 minus 1, and then 2k minus 1, and then k squared, which is our step number 2. All right, let's proceed to step number 3. For step number 3, we are going to add both sides with the k plus 1. So first is, let's add 2 times the quantity of k plus 1 minus 1, and then on the other side we are going to add k squared with 2 times the quantity of k plus 1 minus 1. So here we can say that since this part here is equivalent to our sigma, so we will have this equation. Just copy the right hand side and then change it with our given, with our n is equal to k. Next, let's distribute the 2k, and then 2 times 1 is 2. So here it goes, the result. Next, we're going to combine the like terms. 2 minus 1 is 1. And then, since this part is a quadratic, we are going to factor out. Then the result is k plus 1 times the quantity of k plus 1. Then the last part is, let's merge this one. That becomes k plus 1 quantity squared. So we can say, because since k plus 1 squared is equal to since k plus 1 is equal to n, therefore we can substitute the n here, which is n squared. We can have a conclusion by principles of mathematical induction. The sigma given is true for all natural numbers. Thank you for listening, and God bless us all.